isn't the perfect planet for life. You've been told your whole life that this blue marble is some kind of cosmic jackpot, the ideal cradle for biology. But here's the uncomfortable truth. If nature got a second attempt, if it could start completely over with a blank slate and a clean set of physical laws, it probably wouldn't build Earth at all. It would build something stranger, something wetter, something almost unrecognizable to us. And the moment you understand why, you'll never look at the ocean the same way again. So, what kind of planet would nature actually build if Earth was just its rough draft? You grew up hearing that Earth is a water world. 71% ocean, right? But that number is doing a lot of lying. Yes, water covers most of the surface, but coverage isn't the same as habitability. Most of what people picture when they imagine Earth's oceans only exists in a thin sliver near the surface. Beneath that sliver is a colossal, crushing, lightless void that takes up most of the planet's volume and does almost nothing for life. You are standing on a planet that spends most of its water budget on emptiness. Here's where it gets interesting. Earth also wastes enormous amounts of land. Deserts that stretch for thousands of kilometers with almost no biomass. Polar ice sheets that are essentially frozen wastelands. Even the coastlines, the most productive strips of real estate on the entire planet, only make up a tiny fraction of Earth's total surface area. You live on a planet that looks lush from space and acts like a biological desert up close. So if Earth is this inefficient, this wasteful with its own resources, what would a planet look like if it didn't make the same mistakes? Let's start with Earth's biggest, best-kept secret. The deep ocean is basically dead space. Sunlight only penetrates the first 200 meters of seawater before it's swallowed completely. Below that line, called the photic zone's edge, there's no photosynthesis, no plant life, no foundation for a food chain to build on. And Earth's oceans average nearly 4 kilometers deep. Do the math. The vast majority of all that water is functionally a desert with extra pressure. You could drain 95% of the ocean's volume and barely touch the amount of life it actually supports. But it gets worse. That deep water isn't just empty, it's actively hostile. Crushing pressure, near freezing temperatures, total darkness. The handful of creatures that do live down there survive on scraps, on the slow rain of dead organic matter drifting down from the sunlit world above. It's not an ecosystem so much as a graveyard with a few scavengers picking through it. Earth, the so-called water world, is mostly a watery wasteland wearing a costume of abundance. That's not the biggest problem, though. The real issue is what Earth is missing on the edges. Because here's a rule that holds true across nearly every ecosystem on this planet. Life doesn't explode in the middle of things. It explodes at the boundaries, where land meets sea, where shallow water meets deep water, where warm currents collide with cold ones. Biologists call this the edge effect, and it might be the single most important rule in all of ecology. Coral reefs, mangrove forests, river deltas, tidal estuaries, these border zones cover a tiny fraction of Earth's surface, and yet they contain a staggering share of all marine biodiversity. You would be standing in more species in 1 square kilometer of coral reef than in 1,000 square kilometers of open ocean. So if edges create explosions of life and Earth barely has any edges compared to its total size, what happens if you build a planet that's almost nothing but edges? This is where the real designing begins. Picture an ocean world, not infinitely deep like Earth's abyssal trenches, but shallow. A planet where the seas average just a few hundred meters instead of several kilometers. Suddenly, sunlight isn't a luxury that only touches the surface. It reaches almost everywhere. The entire ocean becomes a photic zone. The entire planet becomes productive. There is no wasted volume, no dead middle layer, no crushing dark graveyard taking up 90% of the water column. Every drop of ocean on this world is doing something. Now add geography. Instead of a few isolated continents surrounded by deep trenches, imagine endless underwater shelves, archipelagos stretching for tens of thousands of kilometers, countless shallow seas separated by low ridges and reef walls. This isn't a planet with a handful of coastlines. This is a planet that is almost entirely coastline. Every single meter of it sits at the boundary between land and sea, light and shadow, current and current. You wouldn't just be standing near an edge effect. You would be standing inside one that never ends. This kind of world has a name in modern astronomy. Scientists call them Hycean planets, a term combining hydrogen and ocean. These are theorized worlds larger than Earth, covered almost entirely in liquid water, wrapped in thick hydrogen-rich atmospheres that trap heat and create stable, planet-wide oceans. They're not science fiction anymore. Researchers studying exoplanets like K2-18b have proposed that this kind of world could actually exist, orbiting distant stars right now, completely unknown to us until just the last few years. But could something like this really host more life than Earth? Or is a planet covered entirely in ocean just trading one kind of emptiness for another? Let's build this world layer by layer, because the answer only makes sense once you see the whole picture. Start with the seafloor, not dark and crushed, but bathed in filtered light, carpeted with branching reef structures that rise like underwater mountain ranges, where Earth has one Great Barrier Reef. This world has thousands, stretching across every shallow sea, every shelf, every ridge. Now add the open water above it, not a featureless blue desert, but layered with drifting kelp forests so vast they form floating canopies, casting shade for entire ecosystems beneath them, the way rainforest canopies do on land. You wouldn't just swim through water here, you would swim through forests suspended in it. Now think about temperature. Water absorbs and releases heat far more slowly than air or rock. That's why oceans on Earth moderate climate, why coastal cities have milder winters than inland ones. On a planet that's almost entirely ocean, this effect isn't local, it's global. No deserts baking under merciless sun, no ice ages locking entire hemispheres in frozen stillness for millions of years. Instead, a planet-wide thermostat, keeping conditions stable enough for evolution to experiment relentlessly, generation after generation, without being wiped out by sudden climate catastrophes the way Earth's life so often has been. Stability plus surface area, plus endless edges. That combination doesn't just support life, it accelerates it. More coastline means more niches. More niches means more specialization. More specialization means species splitting off from each other faster than they ever could on a planet as edge-poor as Earth. Imagine evolutionary innovation happening not in a handful of biodiversity hotspots, but everywhere, simultaneously, endlessly, because the entire planet is a hotspot. And this is where things stop being comfortable, because more competition for resources, more crowded niches, more species fighting for the same narrow strips of shallow sunlit water doesn't just mean more biodiversity. It means faster evolution, harsher pressure to adapt, harsher pressure to outcompete. On a planet like this, evolutionary arms races wouldn't be occasional events. They would be constant. Predators evolving faster, prey evolving stranger defenses, symbiosis becoming more complex, more essential just to survive in such a saturated, competitive world. Some scientists who study planetary biospheres suggest that under exactly these conditions, with this much pressure, this much competition, and this much evolutionary opportunity, something else becomes more likely too: intelligence. Not necessarily intelligence like ours, but problem solving, social cooperation, complex communication, all of it driven by the relentless demand to compete and adapt in an ecosystem with nowhere to hide and nowhere to spread out onto safe, empty land. On Earth, intelligence evolved once in one branch after hundreds of millions of years. On a world built entirely from competitive edges, would intelligence be the exception, or would it be inevitable, appearing again and again in different lineages, in different oceans, on different shelves, all racing toward the same solution from different directions? And if it did, would humans even matter here? Would we recognize what we found, or would intelligence on this world look so different, so distributed, so utterly shaped by water instead of land, that we wouldn't even know how to talk to it? This is the reveal hiding underneath everything you just learned. Earth isn't unusually wet. Earth is unusually dry, dressed up in just enough surface water to fool you into thinking otherwise. Most of this planet's ocean is functionally useless for life. A vast dark wasteland taking up volume without taking up purpose. The real engine of biodiversity on Earth was never the size of the ocean. It was the coastlines, the thin, fragile, criminally undersized edges where land and sea collide. And Earth barely has any of them relative to its size. A true ocean world flips that equation completely. Instead of a handful of biodiversity hotspots scattered across a mostly empty planet, you get a planet that is almost entirely hotspot, almost entirely edge, almost entirely alive. Shallow seas instead of crushing trenches, endless shelves instead of isolated continents, millions of ecological boundaries instead of a few precious ones. If biodiversity scales with edges and edges scale with coastline, then a planet built from coastline alone wouldn't just outperform Earth. It might make Earth look like the planet that never finished what it started. So the next time you look at the ocean and think you're looking at most of your planet, remember what's actually true. You're looking at the smallest part of it that matters. A thin blue ribbon wrapped around a mostly empty world. Earth feels extraordinary because it's the only home you've ever known, and it is, by every measure that counts to the people living on it. But the universe is vast, and the laws of biology don't care about sentiment. Somewhere out there, on a planet with no deserts, no ice caps, no wasted depths, and no shortage of edges, life may not be struggling to survive in scattered pockets the way it does here. It may be everywhere, all at once, endlessly competing, endlessly evolving, endlessly alive. And if a world like that exists, Earth wouldn't be the planet that proves how rare life is. It would be the planet that proves how much further life could have gone.